My impression of what I'm here to do today is to talk about really the intersection of neuroscience and the arts, and in particular the performing arts. The idea that acting can benefit from a much better understanding of how our brain works, and the notion that there are some phenomena that happen in the brain, that understanding those phenomena might enable us to improve the acting method. So this is an idea that has really come up recently for me, and I've become very passionate about it since talking more with Dave about this. And I think that I'm here to answer questions more than anything else, so let's keep this an open dialogue. Let me start by just asking the question of maybe asking you guys to tell me what makes our brain different from any other organ in the body. If you think about the heart, for example, what makes the heart work? How does a heart work? It's mechanical, right? You've got pumping blood, That's a pretty reasonable understanding that we can have of the heart. How does the stomach work? You've got these movements, the peristaltic movements that can move food down, can kind of digest things with acid and with other enzymes and so on. We have a pretty good understanding of how most of our organs in the body work. But if I ask you, how does the brain work? It's a very different problem. It's not easy to just pinpoint, put your finger out and say, here's how it works. We know it has something to do with chemicals. We know it has something to do with electricity. We know a little bit more than that, but really that's it. There's not this fundamental, sophisticated knowledge that we have about other things in the body. So how can we understand the brain better? Well, we understand it by exploring it from a couple of different levels. And I've been fortunate enough to be able to approach it from these different levels. One level is just observing behavior, right? If you want to understand what the brain does or how it does it, you observe people's behavior. You observe what they do. And you'll notice that there are certain behaviors, certain kinds of things that people do that are common across individuals. Attention, memory, decision-making, these are cognitive capacities. Most everybody does them kind of in the same way. So we can start to develop tasks, cognitive tasks, neuropsychological tasks, that test people on these domains and try to understand how their brains work. But we can also peer deep into the brain and ask questions about structure and function. We can use imaging. We can even stick electrodes directly into brains. Mostly not humans, but animals. And we tend to share a lot with animals, so we can learn a lot about how the brain works. Where I am is really at the intersection between behavior and the brain, trying to understand what links those two, trying to understand the fundamental neural substrates of behavior. And we've come a long way in trying to understand this. We've done quite a bit as a field to try to understand how the brain supports behavior, the beautiful behavior that supports something as acting. So my hope is to be able to give you my impression of this today. And we'll start maybe with breaking this down into a smaller set of units, because just asking how the brain works is a pretty big question. It would take me probably a couple of years to try to get that across to you. It takes me 5 years to get it across to my PhD students, sometimes even longer. So what can we do in just the context of maybe even less than an hour? Well, let's focus on just one piece, memory. How does memory work? How do we create a memory? How do we store it? How do we change it over time? And then how do we retrieve it? And then we'll ask the most important question of how can we use that knowledge to improve the acting method. So let's start with asking the question, how can we understand what a memory is? And memories sometimes are a little bit ephemeral. It's hard to put your finger on it. It's hard to understand where a memory comes from, but it is structural in a sense. There are actual changes that happen in the brain every time you do what you're doing right now, experiencing something, whatever that thing may be. Every moment of your awake brain, of just being awake and experiencing the world around you, you're changing your brain. That's what we call plasticity. The brain is plastic, and not plastic in the plastic sense. Plastic as in it changes. It's labile. It's flexible. It is constantly changing. In fact, if it could not change, you would never learn a thing. The environment would never make sense to you because none of it would be familiar to you. You would never have any learning occur. So now the question is, what is that structure? What is that structural change in the brain? And to answer that question, we have to take a look deeper at the brain and start to ask questions about what the functional units are. So your skin is made up of skin cells. Your bone is made up of bone cells, right? Your muscle is made up of muscle cells. Your brain is made up of a very different entity. Neurons, brain cells. They're highly specialized in that, unlike every other organ, every other cell type in the body, these cells can talk to one another. That's pretty special. It's a highly specialized ability. They can use electricity and chemistry to communicate with one another. It's called electrochemical communication. These electrical signals go from cell body all the way down these projections called axons, all the way down to a little gap called a synapse. And they basically send a message down to the synapse that says, release this neurochemical, and this neurochemical will now communicate with the next cell. And that kind of communication is what allows your brain to think, to act, to be creative, to remember, to do all of the things that brains are supposed to do. But what is it that happens at the synapse that makes a memory long-lasting? Because the idea is that if you want a memory to be remembered forever, you have to have a structural change that also lasts, maybe forever. And the answer eluded scientists for a long time. It wasn't clear what that structural change was until more sophisticated studies that have to do with physiology told us that there's actual changes in the physical shape and structure of that synapse, that connection between cells, that strengthens it every time you are encoding something new. Every time you remember, you're learning something new, every time you're experiencing something new, there are physical changes to the structure of the synapses that connect two cells. And this happens over hundreds of thousands and maybe even millions of cells simultaneously. The math itself is mind-boggling. There's 100 million cells, but the connections are much more. There's over a quadrillion synapses in the brain. So if the question ever comes up, do we have enough capacity to store all these things? And if as you get older, maybe you have too much stuff and you got to spill out some of the old to get in the new, you just say, no, this is completely bollocks. We have enough storage capacity to store 30 or 40 or 50 lifetimes worth of information. That's the math. So given that we know how these structures change, how we can support a memory, the question becomes, well, if we know if these small structural changes in the brain are what's needed for a memory, how do we form a much more comprehensive memory, like the kinds of things that we experience on a daily basis? Is it just a whole bunch of synapses get changed? And what does it mean to have a whole bunch of cells strengthen their connections with one another? And it's not so simple. It's actually quite systematic. It's not just that cells change their connections willy-nilly. It's synchronized, and they change their connections in synchrony with one another to build new networks. And that's what happens during development. So when you think about a child, during that sensitive period early on, they're learning all sorts of things. Their brains are changing much faster than your brains are now, because they're building and wiring these networks. What you're doing now is changing those networks. So memories in the adult brain become a lot more about changing the connections between cells rather than building a ton of new ones, although that continues to happen as well. So therein lies the secret, right? We know that memories change the brain, and we know that every time we experience something, it changes the brain. And here's the magic of it all. Your brain doesn't care if it's a true memory or a false memory. Isn't that interesting? Yeah. Does not care in the slightest, right? Because to your brain, it's an experience. So if you fabricated an experience and created a narrative, structurally speaking, you can convince your brain that that is your reality. Ask yourself, if you think of any actor or actress that you look up to, and think about after immersing themselves in a role, and they come out the other side of that role, are they the same person? Think about it for a second. Or have they changed? Acting leaves a lasting imprint on the person and on the brain, and that lasting imprint is essentially that memory, that narrative that they've created. But it becomes part of who they are. It becomes very difficult for the brain to disentangle the two. But that's the magic of acting. That's why it becomes so believable, because in some ways it's not acting at all. It's the reality. Your brain makes it a reality. You've heard already about false memories. You've heard about associations. You've heard about a couple of these things, but I want to kind of drill deeper a little bit and ask, how can you use these things to think more deeply about acting? So in thinking about this process, in thinking about the structural and physical function of the brain and how it changes, there's a few principles that are really important. One principle that I've spent quite a significant amount of time thinking about is the principle of pattern completion. And pattern completion is jargon, so you don't need to worry about the term itself. What it really is referring to is your ability to have the cued retrieval, be able to retrieve a memory based on some cue. So, for example, if you're on a bus and you see somebody's face and they're familiar, the sight of their face might be able to allow you to retrieve their name and maybe the last time you met that person and the exchange that you had. Okay? That cued retrieval process is what pattern completion is. It's essentially a lookup through all of the memories that you have of something that matches or is close enough to an experience that you're currently having, so that you can lump it together and say, this is another instance of that experience. So if I come back tomorrow and meet one of you, and you're wearing a different outfit, I should still be able to classify you as the same person, even though it's a slightly different experience. There's enough of a match there, right? That's the idea. So pattern completion is very important for retrieval of memories, and every now and then, that process fails. And I put that in quotes because it's not clear that it's truly a failure as opposed to something that's evolutionarily adaptive. In other words, you can have a pattern completion process cue back a false memory. You can fool the brain into believing it saw something before. You can fool the brain into believing that it is highly familiar with something because you've got enough cues that are similar, enough cues that are associated, that reactivate some components of this network that was wired, and that's sufficient to reactivate the whole network. The magic of this pattern completion is it only needs a couple of bits and pieces, one or two cues, and all of a sudden you have this immersive experience of going back and living back in that moment that you experienced it. So the more detailed the narrative that you're able to create, the more that you can fool your brain into doing this. So if somebody says, well, you have to figure out some lines in a scene and really put yourself in the shoes of this character, you have to think, well, what is the background on this character? What is their life experience? Where did they grow up? What kinds of experience did they have growing up? What kinds of scenarios can I play in my mind to immerse myself in that role? And those scenarios, that autobiography, that narrative, because you're playing it, and the more vivid that you play it in your head, the better, is going to create those associations for you as if you're actually living it. And as time goes by, the brain does something else which is quite magical. It mixes the two together. It mixes that narrative with the original narrative of your own life, your life story. The reason why your life story usually wins over is because that's much more vivid to you. That has a lot more associations, right? It's real, you've lived it. So how do you get those two to merge? You have to make it just as vivid. You have to live that experience. You have to have so many connections and so many associations with so many things that are close and deep and personal and connected to you in a very deep way to make it a reality. So that in some ways is sort of hacking the pattern completion process, right? It's saying we understand how pattern completion works. Now we can try to use it to our advantage. We can try to use it to create a false memory. And only actors would do this. Normally, everybody would try to avoid this. Everybody wants to have real veridical memories of their lives. Nobody wants to have false memories, right? But this is the craft in which it's necessary to generate those false memories and to really blend the dividing lines between them. So when this process happens, the question is, what happens in the brain? How are these synapses changed? Why does the brain get so confused? Why does it mix them together? And again, the answer eluded people for a long time until recently, maybe the last, I'd say, probably 15 to 20 years, when another principle emerged, the principle of reconsolidation. And I'll start by defining what consolidation is, and then we'll talk about reconsolidation. So the process of consolidation is exactly what it sounds like. It is solidifying an experience. It is making an experience long-lasting in the brain by strengthening synaptic connections. But it turns out that reconsolidation can undo that and can change that. The notion here is that every time that you retrieve an experience and you reactivate those exact synapses, you put them in a state where they are now changeable. They are flexible. Things can be added, things can be taken out, and things can be altered just a little bit. When that happens, the memories themselves can change. And now, of course, you can't say, well, what's reality and what's false memory, because it's all reality. The brain doesn't know the difference. It changed its structure, right? So how does this work? And I'll tell you, the origin of this was a set of experiments in which animals were given an experience. Typically, it's something like shock, right? You put an animal in an environment, you give them a little foot shock. It gives them a high arousal response, gives them a memory, a lasting memory of the environment in which they got shocked, so that they know they should avoid it the next time they go in there. But here comes a very interesting experiment. And the experiment was such that if you put the animal in the environment, but you don't shock him, he's able to retrieve the experience of being there. And the animal expresses fear or a freezing response, right? So that gives you an index of how much memory the animal has for this environment. And that's usually how you measure whether or not memory is long-lasting. And it turns out that if you were to inject the animal with something called a protein synthesis inhibitor, it's basically an antibiotic. Right? Protein synthesis, like an isomycin, for example, is a protein synthesis inhibitor. These synapses, in order to change them, they require proteins. That's the structural building block of the body. So any synapse is going to be made up of proteins. And if you inhibit the synthesis, you essentially inhibit the process of making a new synapse. But here's the funny thing about this experiment. If injected within a very short period of time after the retrieval happened, say about 10 minutes or so, the animal completely forgot that they were shocked. That memory was wiped out completely, just eliminated. And this had kind of an interesting history. Some labs could not replicate this experiment, some labs could, and it turns out that it replicates under some circumstances and others maybe not so much. And there's a longer story there. Should I keep going?
Yeah.
Okay. And there's a longer story there, but the fact of the matter is, every time that the animal goes back into that environment and they're supposed to retrieve that experience again and express the fear, that's the index of memory. And if they're not expressing that fear, they don't have that memory anymore. So where did it go? What happened to it? How can we change a memory so much? And of course, your mind should be automatically thinking, well, can I do this with traumatic memories? Can I wipe out PTSD? Can I wipe out phobias and all of these kinds of things? And that was all the rage for a while. People thought, yeah, maybe this is a great method to just wipe out pathological memories. It's like Eternal Sunshine of the Spotless Mind, if you've ever seen that movie, right? You just zap them, except you're injecting something. But you can zap memories too. You can do it with some of these optogenetic methods, which we can talk about as well. But this was most intriguing. And it turns out that if you look at the chemical structure of the synapse, the protein structure of the synapse, what was happening is that the retrieval experience was putting those synapses essentially in reset mode, putting them in a place where they have to be reconstituted and rebuilt. And the protein synthesis inhibitor was preventing that process. So when you shook off the synapses and they could not be reconstituted and rebuilt, the memory was gone. That was the explanation. And again, there's nuance. It's not exactly, 100% accurate a description. It is the purported description. It is what people think is happening. But this gives us a really interesting tool, right? There's a way now to be able to change an existing memory. And it has to do with retrieving that memory, reliving it, re-immersing in it, and then having something come in and shake off that memory. So there's this idea that memories are not just stable entities, that they change over time. And this idea had lots of different labels to it. Maybe the most recent label to be applied to it is this label, reconsolidation. And to understand reconsolidation, Let me define first what consolidation means, and then we'll talk about reconsolidation. And consolidation is very simple. It's exactly what it sounds like. It is the process of solidifying or making permanent a memory that you store. So that's what you're hopefully doing now. That's what you've done throughout your life. Every time you have a memory, you're consolidating it. And in fact, we now know that there are certain things that will help with that consolidation process. Sleep, very important for the consolidation process. Caffeine helps with consolidation. That was one of the discoveries that we had in my lab. And there's lots of other things that help also. Physical exercise helps with consolidation. But no matter what you do, there's going to be some amount of consolidation that is constantly going on to strengthen the memories that you have on a daily basis. So now what is this reconsolidation business? Well, it turns out that every time you retrieve a memory, there is the possibility that that memory can be altered, changed. Things can be added in, things can be taken out, things can be altered ever so slightly. And the roots of this came from experiments in animals that were given experiences. And in many cases, when you're doing testing, memory testing in animals, you do things that are a little bit impoverished compared to the human condition. So you would do something like a foot shock in an environment. And then when the animal comes back into the environment and you don't shock them, but you want to see if they remember that they were shocked in that environment, you just look for how much they freeze. That's what rodents do, right? If they're put in an environment where they might expect to be shocked, they will have this freezing response. And the freezing is an adaptive response. Normally they use it to get away from predators and so on. So it is what they're evolutionarily wired to do. So we have an index. We have a behavioral index of memory. We measure this freezing response. And we have an experience that we can give the animal. And now the question is, can we change or maybe even eliminate their memory of being shocked completely? And in a subset of these experiments, that's exactly what the investigators did. They had the animal essentially go into that environment after being shocked, after having that experience, and expressing a little bit of the freezing response. And during that retrieval window, that 10 minutes or so that the animal is reactivating that nasty experience of getting shocked, the animal was injected with a protein synthesis inhibitor. This is a particular chemical that essentially makes it very difficult for synapses to be built, for new connections to be built. But it turns out that it also makes it impossible for the synapses that may be broken down to be reconstituted, to be rebuilt. And the result of this experiment is the animal forgot where they were. The animal forgot that they were shocked, and they came back into that environment, and they pretended like nothing happened. So this was most intriguing. And the investigators started to ask questions about, well, what is happening at the synaptic level that is making it so that experiences can just be wiped out, right? That's kind of a really, really important finding when you think about it, right? You can wipe out memories. Imagine the implications for PTSD, for phobias, for all sorts of nasty experiences. Maybe a nasty breakup, right? Wipe it all out. A bad grade, wipe it all out. But these kinds of experiences that they were giving to the animals, of course, were very salient. The animal is living not in an environment like yours. They're not experiencing many things. The shock is pretty much the most important thing that's happened to them because this is a laboratory rat. Our lives are quite different. So to use the same application to humans, it might be much more difficult. Also, it may not have specificity. So how do we know that you're going to be shaking off just one memory and not eliminating a whole bunch of other stuff? Remember, our memories are interconnected. We have a lot of associations. Things are kind of like webs, right? And we want to wipe out very, very particular kinds of experiences, not just everything we have. So the application to the human came in a very different form. It came in the form not so much of wiping out the memory, but in the form of changing the memory. And the idea there is that every time that you retrieve a memory, you put it in a labile state, in a flexible and dynamic state for a little while it's still activated in your brain. And during that time, things can creep in, things can be taken out, and things can be changed. And this happens all the time with repetition and rehearsal. Now, of course, this is deserving of pause a little bit because we were always told that in order to study something well, you have to rehearse it, right? Over and over and over and over. Turns out that that's not always a good thing. So we've also shown that rehearsal or repetition can make some elements of the memory stick and some elements disappear. Contextual details will disappear over time. So if I ask you, for example, what is the capital of the United States? What's the answer? Washington, D.C. Now, any of you, can you tell me, when did you learn that? Recall the exact moment. Kind of tough, right? Do you remember? Do you have an exact moment in time? But there's probably several of these times, right? You've heard that over and over, maybe in school, maybe by parents, maybe by friends, maybe you saw it on TV, all sorts of experiences. That was a lot of rehearsal, a lot of repetition throughout your lifetime. And now you have beautiful conceptual information, semantic information about what the capital is. But all the detail, the context in which you first learned that, disappeared, went away. So that is what rehearsal does. It is good for some things, but not for others. And we demonstrated this empirically just a couple of years ago in my lab also. We showed that just by repeating pictures of everyday objects on a daily basis, that you kinds of objects that you see on a daily basis, just a few times, we're able to make it so that you are much more easily fooled by things that are similar but not identical to them. You're generating more false memories with repetition. That's the third principle, right? So the idea of reconsolidation now, taken into the human realm, maybe into the acting realm, can be taken as the more that we repeat things, the more that we rehearse things, the more potential there is for different things to come in and out. So this experience, this immersion, this character biography that becomes your autobiography, has to be intermixed with your own actual autobiography intermittently, with a lot of rehearsal, with a lot of repetition, over time, not just all at once. It comes as a function of time. In fact, if you sleep on it, it becomes integrated much more quickly, because that's what happens during sleep. These things get integrated. New networks and new synapses are formed. So it's an incremental sort of learning. And over time, your brain can't tell the difference. Doesn't know what's your true autobiography from this character's autobiography, especially if there are bits and pieces that you've tapped into in this character that actually are similar to your own autobiography. If you've created the associations, and it might be difficult if this is a character from the 17th century or whatever it is, but you can always find connections. You can always associate certain personality characteristics, certain pieces, with your own narrative. And those are the pieces you have to find. That's what builds those associative networks. And then your brain does the rest for you. Okay? So we've covered a few things. We've covered how memories are built, what those structural elements are, how they're changed, how networks are built, and really it's just associations, right? Tons and tons of associations, and how these associations can change over time through this process of rehearsal and reconsolidation. So understanding how these things work and understanding that it's actually quite natural for your brain to do this on its own makes acting actually a very natural thing to do, right? It's not, you don't have to go out of your way to do this. You don't have to go out of your way to convince your brain that the reality and fiction are one and the same. It will do the work for you. You just have to make the differences imperceptible. You have to build as many associations. You have to build as many relationships. You have to build webs, interconnected networks. All the bits and pieces have to fall into place. And it has to make sense. If there are things about that narrative that don't make sense to you, then that narrative will not be real to you. And then your brain will know the difference. So that's why you have to find those connections that truly can make sense. How are we doing? Should we open up for questions a little bit?
Yeah, sure. I'm sure I knew
Please.
there would be a few.
If you're creating false memories that might be traumatic, what about the implications of doing that?
That's an excellent point. So the question is,
Which
let's say you're,
actors have to do.
yeah. Let's say you are creating memories that are traumatic. And there's the rub, right? Is that I just told you that your brain can't tell the difference. And traumatic memories are no joke. They can be severely traumatic. And the reality of it is, if your brain can't tell the difference, they will be just as traumatic for you, right? I mean, and you can measure that. You can index it with looking at arousal. You can look at heart rate. You can look at galvanic skin response, pupil dilation, and people when they immerse themselves in these narratives and they're reliving a traumatic experience, even one that has not happened to them, it can be as real as something that did happen. So there's a lot of implications. Does it make for a better story? Does it make for better acting? Well, of course. Can it impact you in a negative way? It's possible. But that's where you might have to draw the line. That's where you have to guard yourself against that. That's where you have to have a little bit of a defense mechanism to say what is the reality and what is not, so that it doesn't merge together. Let me give you an interesting example of this. Have they heard from Beth Loftus yet?
No.
Okay, so I don't want to scoop.
Well, she's not able to make this.
Oh, she's not?
Schedule-wise, it didn't work out, unfortunately.
Perfect.
Okay.
Perfect. I'm going to give you an example from my colleague Beth Loftus's research. One of the issues that surfaced recently, and maybe not so recently, I'm sure you guys have all heard about it, is memories of abuse. People coming forward and reporting repressed memories of abuse. And Beth's research, Dr. Loftus's research, has showed over time that our capacity to generate false memories is just truly remarkable. And she's made it so that you can actually show this in the laboratory. You can show that not just false memories can be retrieved, but you can have people essentially regenerate impossible memories. I'll give you an example of the false one first, then we'll go into the impossible. So false memories, she has people come into the laboratory and look at pictures. These are pictures that have been taken from their own life, and then these pictures were digitally altered to put them in settings and environments that they have never been. So these pictures are things that have never happened. And in a certain proportion of the population, certain proportion of the time, they would generate very vivid false memories of these experiences. So false and so vivid that in fact when they're faced with the truth that these were digitally altered, they're baffled by it and they're in disbelief. And they insist that this truly happens. And they insist that they have vivid recollections of it with all the associated bits and pieces. She's even done things like ask people, I don't remember actually if this was an experiment from her laboratory or from another laboratory, but she had people come in after seeing a story. Actually, there was a story in the news about Pluto, right? This was a story in her lab, Pluto at Disney, having inappropriate interactions with children at Disney. This was a fictitious story that she implanted and that she put in the news. And she basically asked people who might have had similar experiences to come to the lab for some questions, for some testing. And even though this was completely fictitious, it had nothing to do with anything, people were lined out the door coming in and reporting on their experiences with Pluto, an inappropriate Pluto. But here's another funny one. She also had, I don't remember if this was her or another colleague, had people come into the laboratory and report on having experiences at Disneyland interacting with Bugs Bunny.
What?
What's the problem there?
Not part of that franchise.
Bugs Bunny is Warner Brothers and not Disney. In fact, I'm pretty sure that if he gets close to Disneyland, he'll be shot on sight. So this is an impossible memory, right? It's an impossible memory. It could never have happened. And yet people were reporting it. 30% of participants were reporting this impossible memory. So her research and many other colleagues' research in this area has shown over time you can generate false memories like nobody's business. It happens to the best of us, right? There's individual differences, of course, some people more than others, but it happens, absolutely. So then the question of repressed memories came up. People were coming forward and accusing parents and other people and friends and uncles and so on of sexual abuse, of child abuse, of traumatic experiences from their childhood. And they're saying that I went through a hypnosis, I went to my therapist, and all of a sudden all of these things came through. But given now what we know about false memories and how they can be instigated and how they can be implanted, it turns out that actually it's very easy to generate these kinds of false memories in a therapy setting. All you have to do is have a few leading questions. And it turns out that many of the therapists were actually doing this. So Beth's research actually came under a lot of heat because it was suggesting that in some cases, this may not have happened. And in fact, many of the cases that she was an expert witness for and vehemently defended were then exonerated by DNA evidence. So it really tells you that false memories can be very, very traumatic in many cases, right? So for them, these memories never happened. But they were emotional, they were traumatic, they had vivid flashbacks. For all intents and purposes, they exhibited PTSD symptoms. So that's where we have to put up the guard a little bit, right? And understanding how false memories work, as an actor, that should tell you where to draw that line. That yes, you want the experience to have that high level of arousal. You want the experience to be immersive. But at the end of the day, that's where you have to draw that line and say, this was not my life. And that might take a lot of essentially changing the memory back after the role is complete. And that's why it might take some time for a really, really good actor, after doing a really, really good job in a role like this, to really come back to reality. It's not overnight. It doesn't just happen. You have to rebuild those synapses again. You have to change that narrative again to go back to the real narrative, your actual autobiography. Does that make sense?
Yeah.
What else?
So in that case, you know, I've often considered the idea of, you know, from my perspective, I've never seen anybody that was, you know, adversely affected in the long run from performing a role. So I always assumed that there were mechanisms potentially that would somehow be able to differentiate, and I always assumed that would be based on context. I hear what you're saying from the physiological perspective that those may not exist.
Yeah.
So, but having said that, how do we account for this idea that because we can read a book, right? We can watch a movie, and we are affected by the memories that are created from, you know, that experience. Is there a way to account at this point for a difference between an imaginary experience and a what is considered by most to be real experience?
Yes, yes. So fantastic question. So let me recap a little bit. So the idea is that if there is, say, let's take the example of a traumatic experience, something that really causes a lot of physiological arousal. And we want to be able to draw that line between what's real and what's really the role. And the effect of context could not be more important. Absolutely makes a huge difference. And if every time you're re-exposing yourself to that trauma, to that experience, to that part of the fictitious autobiography, it's associated with a specific context. That context becomes that part of the memory. And then it's reactivated only in that context. And that's the beauty of pattern completion, right? That could be the cue. That could be the cue. Once you step into that role, once you step into that stage, once you step into that room, whatever it may be, or maybe you meet the people that are associated with that role, all of them can serve as cues, contextual cues to say, this is the narrative we're working with here. These are the memories that need to be reactivated.
Well, that's good. Yeah.
So the idea is that context gives you specificity. And the role of context is very, very important. And one way to demonstrate this, for example, is taking exams. So if you want to do really well on exams, right, you want to go back and study and do the things that you're going to do in the same room that you're going to take the exam. And what's the reason for that?
Association.
Association, right? Most of us get very much disrupted if you have done the entire course in a classroom and then you have to take your test somewhere else. I've lost my voice trying to explain this to administrators. Let's say, here's the final exam schedule, and you have to go to all these rooms. Like, no, you're going to put them in bad shape if you do that, because then you lose the contextual effect. For me, I can tell you I have a contextual effect with the way that I write papers and I write grants, and it has to do with the sound of an espresso machine. So I usually do it at a coffee shop. That's my context. That's my association. So everybody has their associations, and you'll have your associations that ground you in reality, and then the associations that are role-specific. So context and associations becomes our fifth principle.
We should write that down.
Yes.
So, I think maybe I was misunderstanding you and misinterpreting what you were saying before. But were you saying that you creating a false memory that is close to your own experience, couldn't that be a little tricky in that kind of context, because then you're creating maybe a traumatic memory that's associated with a real memory, and is it more difficult to take that apart?
So it can be. It can be difficult to pull those two apart, but I think the key is really contextual associations. So if there is specificity such that you're reactivating and trying to work on that narrative and build it into a true memory only in certain circumstances and not others, you start to derive networks that are somewhat overlapping but incompletely. They have some components that are similar, some components that overlap with your autobiography, but then there may be other components like the trauma itself that are fairly dissociated, right? And if, I don't know if I can use the whiteboard, but
Don't bring
yeah.
your work home. Kind of thing.
That's the idea, right? Right? Is that it's not so much don't bring it home, but have very consistent contextual influences that are associated with work and consistent contextual associations that are affiliated with home. And one really nice way to think about this is that you are in control of your own memories in many ways. Right? And this kind of runs counter to what I told you before, that the brain just does this all the time. But if you know that it does, you can be in control of that fate yourself. Because now it's essentially your platform, and you can change things, you can build things. You're very well aware that it's going to merge things together, so you can start to give it the right cues to build dissociated kinds of networks.
Okay, here we go. I think this will work for you.
Excellent. All right.
There you go.
So I will try to represent this a little bit and see if
You could give some tips on how to disassociate.
yeah. And yeah, I'll tell you a little bit more about that.
Because we're experimenting with it, and
Yeah.
it can be.
The key is to have cues, right? The key. So you build associations with cues. It's almost like Pavlovian conditioning. Are you familiar with Ivan Pavlov? So Ivan Pavlov is a Russian psychologist who trained his dog essentially to salivate to the sound of a tone, because every time that he would ring that tone, he would pair it with food. So the dog learned after a while that every time he hears a tone, he's going to get food. So he started to salivate just to the sound of the tone. So you can get Pavlovian with this. You can condition yourself under certain circumstances, using certain cues. You are able to retrieve a certain kind of autobiography that is very different, right? And that takes training. That takes a lot of work, but that's what learning to act is really all about, right? It's a lot of hard work. Now, if we think about this from the brain perspective, I'm going to just represent it very, very simply as these spots in the brain, and some subset of them will essentially get wired and connected for an experience. So you might have connections among these guys and so on, and these guys build up a network. So if you get a cue over here, this one will let this one fire, will let this one fire, this one fire, this one fire, this one fire, and all of a sudden all of these guys are going off, right? You have a network resonance phenomenon and a retrieval. You retrieve the entire experience just because you got cued with one piece. But what if you have another experience that uses these guys? Oops, this one's not working. That uses these guys here, right? But also shares these ones. So now the question is, let's say you have this one get reactivated. Are you going to reactivate this memory or this memory? This is a shared cue, right? And these networks are highly specific. This one, you might call this one the real autobiography, and this one might be fiction. And you want to make sure that when you reactivate this one, that it either activates this network or this network. This one by itself won't be able to do that. It has to have differential strength to be able to activate one over the other. But the beauty of this is that we have a lot more associations. We have Pavlovian conditioning, we have cues. So you just have to have other pieces that are connected specifically here, right? So that when this one is activated, it is much more likely to activate these guys, which are all connected over here, and this memory becomes much more strongly represented by this group of neurons. So it really is about the selectivity of the context. And you have to have something that is highly specific that you're activating, something that is contextual, something that is very, very clear cut to tell you which one of these narratives you're operating with. So here it may be the actor's studio, here it may be home, here it may be a coffee shop, here it may be somewhere else, right? But that's the specificity of the cues. If you start to intermix those cues, it can become very difficult. And we actually see it become difficult for professional actors all the time. Again, when they come back from those roles, it takes a while to change back because their lives have been intermixed with the characters they're playing. Sometimes living that fictitious trauma can essentially induce that trauma, right? So understanding the effect of context allows you to do one better, right? Allows you to essentially use that principle to additionally hack the brain. Be able to use this ability to drive a wedge between what's fiction and what's reality. You still want to have this overlap because that's what makes it real, right? But the context is what allows you to separate them. So when you step outside the studio, it's not real anymore. So again, you're in control of these cues. You build your own narratives. You build the pieces. And you control these associations for the most part. When you sleep at night, they get massaged and worked on and changed and so on. But because you know that that's how the brain works, you can start to build those associations yourself.
So by context, do you mean environmental or story-driven context?
Could even be a word.
Word.
It could be anything,
Okay.
right? As long as it's specific, almost hyper-specific. Could be a room, could be a person, could be a word, could be a picture, could be a name, could be a little meditative exercise that you do right before. Whatever it may be, it's your context,
Okay.
right?
You know,
It's highly personalized.
Yeah.
Let's ask a specific question because I like where this is going. This actually could open up a new sort of part of the technique for us, to be honest. But let me say this first, though. When we create our memories, we actually do design memories. The process that we use is very specific. The first thing we do is we float above the scene in our imaginations, looking down upon ourselves as the character and the other people that are in the room. And so I call that my disassociative view, right? Because we're looking down upon the scene. That's how we use our imagination to create the pieces in the environment, right? Then we float down into the body of the character, looking through our own eyes, and then look around at the space. And then we begin the event, right? And then we talk ourselves through an event using sensorial details, like what do we see, hear, feel, or also thoughts, what do we say to ourselves? And then we even add a kinesthetic element in terms of the quality of the movement that occurs at the moment we want to encode this specific event, right? So, so having said all that, and I'm sure that's all rudimentary to you, the idea of context, the idea that we're actually creating these memories ourselves and always starting with the idea of floating above, could that in and of itself be the context from within which our brains decipher between this imaginary memory and everyday instance?
Yeah, no, absolutely. I mean, I think anything can really be a context. And if you've got, this is what I meant by sort of a premeditative exercise, right?
Right.
And that's exactly my point, is that if there's something that you do to cue yourself into the role,
Right.
that can serve as a really good context.
Okay, great, awesome. I just want to make sure everybody that everybody's comfortable with our process.
It makes a lot of sense to me.
Yeah,
It makes a lot of sense to me because it really gets you into the associative mode.
Right.
And being able to figure out what other characters and what the scene looks like from above is very, very similar to the kind of recollection that you have when you think of a memory that's way past. You think about everybody else that was there. You have sort of this bird's eye view of it, and then you kind of can visualize where the people were and what kinds of experiences were there. And that experience, that sort of super recollective experience, is one that not everybody is able to experience very well. So I firmly believe that there's individual differences in the ability to experience memories, and I think that probably acting selects for individuals who can do this better, who can have recollective memories that are very vivid, that are highly imaginative, that are highly creative. In other words, when you put yourself back in that scene, you can almost smell it. You can feel it. You can visualize the colors, all the vividness of it. It's not just this blank semantic kind of memory. It has a lot of detail to it. The more detail, the more cues, the more context.
So one thing that also interests me, I want you guys to ask questions about this, but I think there's another application here when Dr. Yassa is talking about cues. What do you guys think about that, and do you have any questions about that, or any other things that you have on your own? But I'm just throwing that out there because it's something I think that fits into what we're doing. Cues that recall an experience, right? Because how similar is that to our stimulus, choosing our stimulus? Yes, Kevin?
Kind of lost the, especially for cues and then for traumatic experience. Since if you use the cue based on your own real experiences, would that intensify the real traumatic experience that you had happened before? If that's clear.
So I can give you an example. One of the things that's really important about making the living of a traumatic experience become real, or the imagination around it becoming real, is that it has to be linked and associated with things that deeply trouble you personally, that connect with your own narrative, that connect with things that are personally traumatic. That may not come out in the narrative, but that's going to be where your physiological reactivity comes through. That's where your arousal, your pupil dilation, your galvanic skin response, your heart will race, your skin will start to sweat. All of these kinds of things will come because of the reality of it. So linking that with something that is personal to you, that might have led to that high level of arousal for you, can make it much more real. So that could become the cueing procedure that you would need to elicit the arousal associated with this experience. Does that make sense?
Yeah.
And can we also just, and that could be a conscious association, but it could also be as effective as an unconscious association, correct, as well?
Absolutely, absolutely. In fact, it's probably much more effective if it is unconscious.
Right,
If it just happens naturally,
right.
it will become much more effective, as opposed to saying, oh, I'm supposed to remember this thing that's associated with it.
Right.
If it gets paired a couple of times, over a few days, as you sleep, your brain is just going to merge it together and it will become implicit. It'll become an unconscious connection. So that it will always remind you of that. That's the beauty of associations and pattern completion. It just happens, it's automatic, right? That part of it you don't control so much. Once you have a cue, it is an automated retrieval process. Yes.
You said that synapses are made of proteins and they require protein to change.
Mm-hmm.
Does a person who has a diet higher in protein have a higher rate of remembering or creating memory?
Fantastic question. No. No, the protein that you eat is unlinked to the kinds of protein that we're talking about, because at the end of the day, you're actually made up of protein. Every part of your body is made up of protein. So there's something called the central dogma in molecular biology, which is that your DNA is transcribed to RNA, right? So DNA to RNA, and then the RNA is translated to protein. And proteins are the building blocks of the body. So every part of your body is made up of protein. So when I say proteins, I really mean the structural building blocks. If you're on a protein-rich diet versus a protein-poor diet, it's not going to make much of a difference, although a protein-poor diet probably won't be good for you in the long run, right? So sure, you should have a diet that has got adequate amounts of protein, but it will not influence whether or not you can make synapses. Does that make sense?
Yeah.
Because the kinds of proteins that are being made in the brain, being made in these synapses, come directly from RNA that is transcribed in those same cells. So the DNA in the nucleus of each one of those cells transcribes RNA, and the RNA in each one of those cells will make its own protein. The protein itself does not really traverse from one cell to another. So getting it from food to go into the cell is not going to happen. Those are macromolecules. They're too big. They'll never go through the cell membrane. Does that make sense? So all we need is made directly inside the cell. Yes?
Speaking of rehearsal process, so you said there are pros and cons for rehearsing.
Uh-huh.
Yeah, certain things. And then is there like a maximize only the benefits of rehearsal?
Sure. So the question is about rehearsal and the pros and cons of rehearsal. And I should clarify and say there are many more pros to rehearsal than cons. I think the cons are something that you have to be aware of. And the question is, what is it that you're trying to learn? So our education has shifted. You probably noticed over the last 50 years. Education has shifted in general. Now, things that we can look up on Google, on Wikipedia, there's not a lot of impetus to store that, right? So all these details that we can just look up online or in a table or in a book, that detail is not all that important anymore because we know there's so much of it out there and we can just look it up. The important thing is concepts, semantic memories, conceptual information. And rehearsal is really good for that because it takes the context out and focuses on the center, right? Focuses on the centerpiece. So the capital, Washington, D.C., you know that now. That was a semantic piece of information. All the detail doesn't matter. Will you ever have to answer the question, when did you learn that and how did you learn it? Only I ever asked you that question, right? You never have to answer that otherwise. So to think about what is the principal reason or what is the principal mode by which we learn everyday kinds of things, you'll notice that rehearsal is required for that. But I will clarify one thing. I'm not saying that you should be rehearsing and saying things over and over to yourself every day because as you sleep at night, your brain automatically rehearses for you. That's what happens during slow wave sleep, your deep sleep, delta sleep. As these slow waves are happening during the period in which you sleep, there are very short bouts of what's called sharp wave ripples. These sharp wave ripples are essentially information packets that transfer information across different places in the brain that allow you to replay and reactivate the memories that you've experienced throughout the day. They replay things very fast, about 8 to 12 times as fast. And the reason they can do that is because they're not locked to real world time. They're now in synaptic time, right? You're asleep, you're not having an experience anymore. So experience in the real world is actually slower than how our brain operates. Or in other words, our brain can probably handle the world speeding up by a factor of 8. It's kind of sci-fi, I know. But if we were to somehow press fast forward on the world around us right now, we can fast forward up to 8 times and our brain can still process it reasonably well. Although I probably shouldn't say that on the record. I don't think that is a testable hypothesis. But I guess we can do it with a movie. But that's the idea. Reactivation happens during sleep. And it has nothing to do with dreams, by the way. It's not so much REM sleep, rapid eye movement when you're dreaming. This is slow wave sleep. So it is imperceptible to you. You will not feel it. You will not feel this reactivation happen. But we can pick it up. We can detect it both in humans and in rats and in monkeys and across animals. Very, very powerful automated rehearsal technique. Your brain just does it for you. Other questions?
Oh, yeah, okay.
Yeah. How much sleep do you need for that to happen?
How much are you sleeping?
Like 8 hours.
That's good.
I like more.
Yeah? So, right, so there's a formula. And it's not the same for everybody. And the question of how much sleep does every person need, the answer to that is very simple. It's the amount of sleep that you need to be okay during the day, being awake and not feeling tired. That means you're not falling asleep at the wheel, you're not falling asleep in class, you're not falling asleep during a lecture, you're not falling asleep while you're hanging out with friends, you're not falling asleep on the couch in front of the TV. If any of that happens, you're probably not sleeping enough, which means you're all sleep deprived. It's okay, it happens in college. Everybody's sleep deprived. Yeah.
But people say that your body wants more hours of sleep if you like continue to get more hours of sleep.
That your body is somehow going to require more hours of sleep if you sleep longer.
Yeah.
I don't think there's any basis for that in the scientific evidence. Yeah. If your body is sleeping more, it is your body telling you that it needs more. Now, I want to dissociate and clearly dissociate between sleeping and laying in bed. Those two are very different. So when you look at a hypnogram that shows you the sleep stages, the important thing about sleep structure is that you have to get as much of it in stage 4 sleep as possible. If you're laying in bed 8 hours, but you suffer from insomnia or sleep apnea or any other sleep disorder, which are easily diagnosed and highly treatable, then it's not really getting 8 hours of sleep, is it? It's getting 4, 3, maybe 1. Sometimes you don't even know. But sleep studies are useful things to do, and you can just go get a sleep study. If you suspect that you might have a sleep problem, you can go get a sleep study, and they'll show you exactly what your hypnogram looks like. They'll show you how much time you're spending in the different stages of sleep. Every time you wake up, it'll be obvious to you, right? And if you wake up in the middle of the night, have trouble falling back asleep, that's also a problem. Yeah.
So when you are sleeping at night and you are reactivating a memory,
Mm-hmm.
does that have anything to do with semantics, like memorizing lines, or is that more with experience, like memories?
Everything.
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 So instead of rote memorization, sleep could help.
Mm-hmm. That's exactly what it does. Anything that you store, whether it is semantic, conceptual, experiential, maybe a skill like learning a new instrument, whatever it may be, all of it gets reactivated at night. Yeah.
How does stress affect?
Remember everything I told you about sleep? You can just put a negative sign in front of that.
Right, so it can negate the positive
Absolutely.
effects of sleep.
Absolutely.
So if you're stressed out while in a rehearsal,
Yes.
it can make it impossible for you to encode that information.
Yes. In fact, work from UCI has shown that high levels of stress, corticosteroid binding, essentially impairs memory. Makes it very difficult for you to retain that information. So yeah, that's the upshot from today. Sleep good, stress bad. Right? Physical exercise, really good. That also helps store memories.
Oh, really?
Yeah.
I didn't know that.
And caffeine also a little bit. I keep pitching caffeine as I drink my coffee. But not close to bedtime.
So I have another question, and I don't even know if this is
Yes, Professor.
in your wheelhouse, or anybody's wheelhouse. One of the things that one of the challenges we have is that we need to take words on a paper that are written out and then bring them to life through our living process, right? In order to do that, I've often talked about, well, what are the mechanisms that we use when we're just speaking like we are right now, creating our own words, and how do those mechanisms differ from what we have to do, which is really the one, in my mind, it's the only thing that really has to be artificial about the acting process, is we have to say words that somebody else wrote, right? It's the one thing. So one of the thought processes that we've talked about in here and we're considering and going on is, so how are our thoughts, right? What are our thoughts in terms of data that is stored, and how are those thoughts then transformed into these words that represent ideas that we express? Is there a way in your mind to even though we have to already know the words, replicate the process of thinking of the words in real time? Does that make sense?
Yes, it makes total sense. I don't have a prefab answer for you, so I'm going to just go off the cuff here and say what I might think was something worth trying, because this is an experiment, right?
Yeah, totally.
And one of the so I can tell you from the learning literature, from the educational literature, reading and remembering lines verbatim never works in the educational realm. Mm-hmm. For acting, it's different. Mm-hmm. But keep in mind that when we're teaching you a subject like science, we don't want you to remember the exact words. We want you to remember the concept. Mm-hmm. And one of the things that we teach students to do is to paraphrase, to remake the words, to say those words out loud to themselves, and not just hear them as words, but do what's called deep encoding. Let me give you an example. This is an experiment that has been done many, many times, but it goes back to the 70s. I can give you a list of words, and I want you to be able to remember that list of words later. So just rote memorization, right? But there's several ways that I can get you to encode that list of words. One way is to get you to go down the list and tell me for each one whether it's written in capital letters or small letters. Tell me if it's uppercase or lowercase, right? So you go down the list, you say uppercase, lowercase, and so on. So that's a very shallow encoding task. All you did was just look at the words and then report something about some property of the words. There's an intermediate task that I can ask you. For each word, tell me if it rhymes with hat, right? So you can read cat rhymes with hat, for example. And you can say rhymes does not rhyme, rhymes does not rhyme, and so on. So that's another type of task. It requires you to say the word out loud and see if it rhymes. So now you're sort of a level deeper in encoding, but it's still not very deep. But then the third experiment, the third level of encoding, the deepest sort of encoding is see if it makes sense in this sentence. The man ate his, fill in the blank. Right? So now you have to put it in the sentence and ask yourself, does that sentence make sense? Right? That's a deep encoding. That's a very different kind of experience. This is called the levels of processing effects. And there's lots and lots of work on this in cognitive psychology and cognitive neuroscience. Turns out that the levels of processing effect essentially explains why is it that when we deeply encode something, in other words, we ask ourselves much more complex questions about that material, that sticks. Now, the question is, does it apply to lines? And I don't know, but I think it's an experiment, right? Instead of just paraphrasing the lines, the question is, if you read those lines out loud, can you formulate questions about those lines? Can you ask them in sort of Jeopardy way, right? Can you formulate some sort of question about them so that the response is that line? Can that line make sense to you or make an association with you? There's some way that it can link up with something else that you might have. So it's not just a line anymore. It's not just a shallow encoding task anymore where you're just reading lines. Now it's a much more deeply encoded task. That's an experiment worth trying.
Yeah. Yeah, for sure.
And you let me know the results?
Yeah.
We'll do it with controls and everything?
Yeah, sure. Yeah, here's this side and this side.
All right. Experiment 1 in the actor's laboratory.
So I love that. A deep encoding of the concept is something that we can definitely spend time on. And a step further then, in your, from your perspective, how do you think that thoughts are stored? Maybe I don't want to lead that question. So how do you think thoughts are stored? Like when we're constructing sentences right now as a need to express an idea, it's happening because of what process and how are those?
Yeah. So the question is about constructing thought processes, right? Which is a very, very big question, Dave. I don't know if I can answer that question in a pretty short narrative, but I'll give you the pieces that really need to be put together in order to construct sort of a thought process. You need the perceptual and sort of sensory motor processes, which is low level, right? That's easy. That's, you're visualizing something, hearing something. Okay, that's pretty straightforward. What about the more complex stuff? One thing that's going to be very, very important is answering the question first about why we have memory. So I want your answer. Why do we have memory? Why is memory important? Not for acting, just for living.
They make us create who we are.
Yeah.
They make us who we are.
We can do things.
So you can do things. Who cares?
Danger.
Wait, say again?
So we can avoid danger.
Avoid danger, right? That's the evolutionary argument. Making us who we are is sort of epiphenomenal, right? Who cares? We could be all the same. We could be the Borg, right? Nobody cares. The important thing is we survive. We survive. How does it do that?
Because of if you get your foot shocked in one environment, you'll remember it
Exactly.
next time.
Exactly.
Because you don't want that to happen.
Yeah. You're trying to avoid predators. You're trying to promote your survival, which means you have to remember what is a threat. You have to remember when something has threatened your existence and your survival. So it turns out that memory is not there to remember anything at all. It's really there just to be able to predict the future. And every time you're constructing a thought, you're trying to match up your prediction with what actually happens. And every time there's a discrepancy between those two, there's an opportunity for learning. So we are constantly testing our predictions. And you can test this out right now. As you start to read a book, you will notice yourself, the way that you read is that you're anticipating what's going to come next. And that's why surprise happens. That's why when something happens that's surprising, is because it violated your prediction, right? What happens when something is surprising? Is that exciting for you?
Yeah.
Well, of course it's exciting, right? It's a novelty effect. When there is surprise, when there's a violation of our prediction, the brain goes, wait a minute, I was wrong. That means this is important. I've got to learn this. It turns out that biologically speaking, novelty and surprise release a certain neurochemical in the brain that is the same neurochemical that is released when you're really, really happy. It's called dopamine. It's the brain's happy juice. It's what happens when you have a really good meal. It's what happens when you have sex, right? This is your brain's happy juice. When you're surprised, happy juice. So in constructing the thought process, there is this constant attempt to predict what's going to happen next, predict what's going to come next, and then either that gets confirmed, and then you move on, and it's great. Your brain says, hey, we're doing really well. Okay, keep going, keep going. All of a sudden, you get a surprise, something you don't expect, and it says, there's an opportunity to learn that. So that's why when you still don't know the lines, when you're still working on them, your brain is constantly getting surprised. And these are opportunities for additional learning. But eventually, when it becomes automated, the brain is not learning anymore. It all just goes into complete auto drive. You don't need it anymore. You don't need that complex prediction machine anymore. So the question of how to construct a thought, I would say that aside from the sensory motor pieces, the things that happen on the visual and auditory side, the kinesthetic side, and then things that happen on the side of you actually issuing that thought to your consciousness and making a decision, saying words, saying something about the thought, that magic black box in between is a combination of memory and prediction error. Whenever you read something, whenever you experience something, you're constantly comparing it to, what do I know in my memories that might match with this, that this might get integrated to, that makes sense with this? And if that allows you to predict the next thing, great. If you predict and you're wrong, even better, because then you learn. Right? That's why children learn so much. Their predictions are constantly getting violated. Does that make sense?
Not only does it make sense, it's correlative to a writing technique, and that's like the backbone of story structure is when does the hero of the story when does the event creates outcome different from their expectations, and when that happens, then that's a turning point in the story.
Absolutely.
So writers actually use that as they're creating the scenes that we're performing.
Well, writers and cinematographers and producers and directors, they've known all this for a long time. Neuroscientists are behind. We're just trying to put biological meat to it. Right? But yeah, these are the things that work, not just anecdotally, but it is tried and true. And they work for a reason. They captivate attention. Novelty captivates attention. It's a device that's used all the time. Do you want movies to end in a very predictable way, or do you want a twist? Everybody talks about twist endings, right? Mm-hmm. They're great. Why? They violate your predictions. When that happens, you get happy. Dopamine happy. Not dopey happy, dopamine happy. But close.
That's awesome. So any other questions for Dr. Yassa about pattern completion? Anything? We've gotten a ton more today to chew on for sure. Right? Okay, my excellent
Thank you,
friends.
guys.
Thank you so much for
Much
coming.
appreciated. Thank you.